Good morning, Dr. Lee. So this is our group presentation by Christian from 304 and me, Teck Kong from 307. So we'll be presenting about elements from period 2. So this is our content outline. So firstly, I'll be going through about the electronic configuration. Then next, I'll be going through on the important electrodes for the elements. Then I'll be going through the trends in the physical/chemical properties across the period. So Christian will be going through the important chemical reactions for the elements in the group, and he will also be going through the important chemical compounds formed from the elements in the group, as well as their Lewis structure and their applications. So firstly, the electronic configuration. So an element in period 2 has its valence electrons in its second shell. So an element in period 2 obeys octet rule, so it requires 8 electrons to complete their valence shell. So the second valence shell has 2 subshells, namely the 2s subshell as well as the 2p subshell. So the 2s subshell can contain up to 2 electrons, while the 2p subshell can contain up to 6 electrons. So these are the electronic configurations as well as the elements of all the elements in period 2. So this is the trend for the period 2 elements. So firstly, for period 2 elements, the atomic radius decreases across the period, meaning as the element moves from left to right across the periodic table, the atomic radius decreases. So this is because the valence electron of the element increases, however the core electrons still remain the same. Therefore, the effective nuclear charge of the element increases, but the electron shielding of the element remains constant. This causes the element to have a greater attractions to the electrons, thus pulling the electron cloud closer to the nucleus. The electronegativity also increases across the period. This is because across the period, the charge on the nucleus increases, and this causes the element to have a greater attraction for electrons. The ionization energy also increases. Since the charge on the nucleus increases, there's a greater attraction between the electrons and nucleus, and thus more energy is needed to remove an electron. So next I'll be going through the important allotropes of carbon. So carbon is capable of forming many allotropes due to its valency. So carbon has an electronic configuration of 1s2, 2s2, 2p2. So each carbon atom can form up to 4 chemical bonds to other atoms. So carbon atom is just the right carbon atom is just the right and small size to form covalent bonds, which explains why it is capable of forming many allotropes. So the allotropes I'll be going through will be diamond and graphite. So firstly, diamond. So diamond has a giant covalent structure, and each carbon atom is joined to 4 other carbon atoms by strong covalent bonds. So this forms a tetrahedral network structure within the diamond itself. So one of the properties of diamond is that is the hardest known natural material, and this causes it to function as an industrial abrasive for them to cut hard materials. It also functions as jewelry and has a very high cost for some types of diamond. So another allotrope of carbon will be graphite. So the structure of graphite is such that each carbon atom is joined to 3 other carbon atoms by covalent bond, and that the carbon atoms form layers with a hexagonal arrangement of atoms. So one property of graphite is that there is a good conductor of heat and electricity, and this causes it to function as well as an electronic product, such as electrodes, batteries, and solar panels. So graphite can also be used as a lubricant, and it can also be found in our pencil. So next I'll be going through about on the important allotropes of oxygen. So the first important allotrope of oxygen will be ozone. So ozone has a chemical formula of O3 and is one of the reactive allotropes of oxygen. So ozone is formed by the reaction of O2 with atomic oxygen produced by splitting of O2 by UV radiation in the upper atmosphere. So ozone helps to absorb ultraviolet light and functions as a shield for the biosphere against damaging effects of solar UV radiation. Last but not least, the last allotrope of oxygen will be, of course, oxygen gas. So oxygen gas has a chemical formula of O2. So it's a requirement for aerobic respiration, and is something that we need for us to breathe. Therefore, it's something extremely important. So it's something that is also needed from combustion and makes up for roughly 21% of the atmosphere.
Now I'll be talking about some of the important compounds containing period 2 elements. First, we have lithium. Lithium salts are commonly used as mood stabilizing drugs, for example, lithium carbonate. This is because lithium salts are able to treat symptoms such as mania and depression. Also, lithium is found in lithium cobalt oxide, which is used in lithium-ion batteries, which are a type of rechargeable battery which are commonly found in electronics. Next, we'll be talking about carbon. Carbon is present in all organic compounds. Hence, it's incredibly important as it's necessary for life. Also, carbon is also found in carbon dioxide and methane. These two are greenhouse gases. Due to human activity, the levels of these gases in the atmosphere have risen drastically. Hence, they tend to trap more heat and have raised the temperature of the Earth in the recent years. Next, we'll be talking about compounds that contain nitrogen. Nitrogen compounds such as ammonium nitrate and urea are important fertilizers. This is because plants, being living organisms, require protein, and protein needs nitrogen in order to be synthesized. Hence, ammonium nitrate and urea are used as fertilizers as they act as a source of nitrogen for the plants. In addition, nitrogen can also be found in amino acids. Amino acids are an important building block for life as they are the fundamental units for proteins. The next compounds we'll be talking about contain oxygen. First, we have water, which is an incredibly important molecule. It acts as a solvent for most reactions in organisms, so it's very important for life. Also, oxygen is found in carbon dioxide and nitrogen oxides in the atmosphere. Uh, Oxygen can also be found in oxyanions such as sulfate and permanganate. Sulfate is commonly found in salts and is also used commonly as an acid in sulfuric acid. Permanganate is also useful as it is a very common oxidizing agent, most commonly used as potassium permanganate in lab conditions. Oxygen is also found in many organic compounds, for example, esters. Many esters have fragrant odors and are hence commonly used in perfumes and flavorings. Oxygen is also found in adenosine triphosphate, which is used on the cellular level to store energy. Next, we have important compounds containing fluorine. We have Teflon, which is a polymer containing fluorine atoms. Due to Teflon having a very low coefficient of friction, it's very commonly used in things which require low friction, such as non-stick pans and raincoats. Now, we'll be talking about some important chemical reactions involving these elements. The first is the decomposition of 2,4,6-trinitrotoluene, more commonly known as TNT. This reaction is very exothermic and it's also explosive, so it's very important as it has applications in industrial, mining, and military purposes. There's also the Haber-Bosch process, which is a synthesis of ammonia from elemental nitrogen. This is important because ammonia is an important precursor to fertilizers such as ammonium nitrate and urea. However, the nitrogen-nitrogen triple bond in elemental nitrogen is very strong and hard to break. So it was only in the 20th century that a process was developed to efficiently carry out this synthesis. There's also amidation. Uh, Amidation is important because it's used in the formation of proteins. Amino acids contain both a carboxylic acid group and an amino acid group, an amine group. So these two groups will condense with each other and form an amide bond. This process continues and allows multiple amino acids to join together and polymerize. They form a polypeptide chain which is folded into a protein, which is important for life. There's also combustion. Combustion is an oxidation reaction where fuel is combined with oxygen. It's usually quite exothermic, so it's humanity's main source of energy.